Hello, in this session I'm going to talk about sines and cosines when the angles are more than 90 degrees. In an earlier session, I've talked about the meanings of sines and cosines in terms of a triangle, a right-angled triangle. So as a quick recap, that's the angle theta, that's a right-angled triangle. Now, if the hypotenuse is r, that's the opposite to the angle y, that's the adjacent to the angle x. We know, for example, that sine of the angle theta is equal to the opposite y over the hypotenuse, and cosine theta is equal to the adjacent x over the hypotenuse, and tangent theta is equal to the opposite over the adjacent. So we have understood the meanings of sine, cosine and tangent using this right-angled triangle. And the angle here is one of the angles, is the acute angle in the right-angled triangle. Now, and since it's an acute angle, this angle must of course be less than 90 degrees. So what exactly do we mean if the angle is more than 90 degrees? Can I talk about a sine of 120 degrees, for example? How would I draw a right-angled triangle for that has an angle of more than 90 degrees? That's not possible. So the idea is to extend the meaning of sines and cosines in a way that is different from just using the triangle itself. And we do it using the xy coordinates. We do it using a graph. And the reason why we want to do this, we'll see afterwards, is that we can then use sines and cosines to help us to calculate things like the sides of triangles. Alright, so now let's first look at how we can talk about sines and cosines of, say, 120 degrees. Alright. The trick is to make use of the graph. Now on the graph, I have two axes. I'll call that horizontal, the x-axis, and y, the vertical axis. That's the origin. Now I can imagine drawing a triangle there, like that. So that's the same triangle as this one. This is a right angle triangle and that angle is theta. Okay, so the adjacent is x, opposite is y, hypotenuse is r. Same triangle, no difference. What about when the angle theta is more than 90 degrees? Right, let me rub that away. What if that's my angle? The way to define a sine, cosine and tangent for such an angle is to draw the right angle triangle there. We cannot draw a right angle triangle that has an angle that is more than 90 degrees. So we are simply drawing the right angle triangle on the other side of the graph. So now we have a right angle triangle, and the angle in the triangle is not actually theta, right, but it's on the other side of the line. It's actually 180 degrees minus theta. So this is the way the sine and cosine are defined. So for example, if we have this distance x and that distance y, sine and cosine and tangent are defined in the same way by the same formula. But the answer could be different, because if I have the x on the left side of this graph, the x here is actually a negative number. So that means that if I look at cosine, for example, cosine is x over r, cosine is the adjacent divided by the hypotenuse. Now in this case, this adjacent is taken to be a negative number, because we are going to take the negative x value. And if I put a negative number in the x, then I will get a negative answer for the cosine. So things will change. The sign could change, even though the numerical value does not. So just as an example, let us think of an angle. Suppose that this is 150 degrees. Alright, now then we can find that this angle is 30 degrees. Now we know that 30 degrees is a special angle. We've learned that in an earlier session. So if this angle is 30 degrees and if the hypotenuse is 2, then the y will be 1 and the x there will be equal to root 3 over 2 with a minus sign. Alright, so we know the values of all three sides of the right angle triangle when one of the angles is 30 degrees. So this means that we can use this length to calculate the sines and cosines. So let's try that. Now, so for this triangle, I have the angle of 150 degrees. So sine of 150 degrees is y over r. In this case, y is pointing up, so the value of y is positive, and I have 1 over 2 as the answer for sine 150 degrees. What about cosine of 150 degrees? Right, that would be x over r. Now in this case, the x is on the left side of the graph, so it has a negative value. It's minus root 3. There's a mistake there. It's just minus root 3, not over 2. Let me write that down out again. So the value of x is minus root 3. So that's the length of that in the negative direction. So we give it a minus sign. So x over r would be minus of root 3 divided by 2. So you see, now we gain a negative sign. The cosine of 150 degrees has a minus sign. That is something that we do not see if we just look at a simple triangle. If it is just a simple triangle like that, and we find the sines and cosines of the acute angle, the answer is always positive. But in this case, when we extend the idea of sines and cosines to angles that are more than 90 degrees, we do it using this graph paper, using the x and y axis, and then we extend into the side where the x values can be negative. So that's why when we find the cosine, which is x over r, we end up with a negative number. Let's complete this calculation by finding the tangents. 150 degrees. That would be y over x, opposite over adjacent. So y is plus 1, x is minus root 3. Minus root 3. So tangent 150 degrees is also a negative number. So I have a negative and negative for cosine tangent and a positive for the sine. So that's the kind of thing that we would expect when we look at angles that are more than 90 degrees. We would expect the sines and cosines to have the same value for the corresponding acute angle. So I would say, for example, that if the angle is 150 degrees, the corresponding acute angle is 30 degrees, because that's the angle that I get if I draw a triangle on the other side. So we get the same numerical values for the sines and cosines, but the sign of the number can be different. It can be positive or negative. And this is also the kind of answer that we will get if we use a calculator to calculate, say, cosine of 150 degrees. The calculator will give us maybe a decimal number with either a plus or minus sign. Okay, so let's take a look at other angles. Now, I've looked at 150 degrees, which is an obtuse angle. Is an angle between 90 degrees and 180 degrees. What if the angle is more than 180 degrees? Well, let's take a look. Alright, let's look at an angle of 210 degrees. That's the reflex angle, more than 180 degrees. So we need to extend the meaning, the idea of sine and cosine, by drawing a right angled triangle down here. We must always make use of the acute angle, because a right angled triangle can only have acute angles. So I would have to draw a right angled triangle there. Now, one thing you might notice is that I always want the x-axis as one of the sides, alright, as the adjacent. We do not use the y-axis as one of the sides of this right angled triangle. So that's another thing that we must remember when we think of the meaning of sines and cosines of angles that are more than 90 degrees. Right, so that's my right angled triangle. So once again, if I find this acute angle, I'll get 30 degrees, because that's 210 degrees minus 180 degrees is 30 degrees. So that again is a special angle. We have sides that are the same as before. If the hypotenuse is 2, then the opposite is 1, and the adjacent there is root 3. Now what about the signs? The root 3 here is on the negative side of x, so it'll be minus root 3. Now this time, the 1 here is on the negative side of y. So therefore, it should be a minus 1 for this side. So both the adjacent and the opposite of the triangle now have negative signs. So that would be the x and the y, and they would go in here. That's the y, the x, the y, and the x. So the negative signs will go into this formula, and we can use the same formula, right? Once we have drawn the right angle triangle and understood what are the sides and what are the signs, we can simply use the same formula as before. So let's try that. Now we are talking about an angle of 210 degrees. So that this is sine 210 degrees, right? And we understand that we are supposed to make use of that right angle triangle, which has the acute angle of 30 degrees, and since sine theta is y over r, sine theta is the opposite over the adjacent, that would be minus 1 over 2. Minus half is the answer. Cosine. Cosine 210 degrees is given by, again using that triangle there. The adjacent is minus root 3, hypotenuse is 2. So minus root 3 over 2. So that's the cosine. And finally, the tangent. 210 degrees. Right, that would be opposite over adjacent, minus 1 over minus root 3. Minus 1 over minus root 3. So minus and minus cancel. We have a positive answer. So there we have all three ratios. Sine and cosine are negative, the tangent is positive. So we have looked at this side, an angle up there, we have looked at an angle up there. What if the angle is down there? Now before I talk about an angle there, it would be nice to have some way to describe each part of this graph. And the name that is used to describe this quarter of the graph is a quadrant. Right, so each of this is a quadrant, and that one is called the first quadrant. This is called the second quadrant. This is called the third quadrant, and that is called the fourth quadrant. So we now understand how to find the sines and cosines in the first, the second, and the third quadrant. What about the fourth quadrant? Alright, now suppose I have an angle of 330 degrees. That's a very big angle. It is this angle there. Right. Now to find the sine and the cosine, once again I need to know where to draw the right angled triangle, and in this case we draw it in the fourth quadrant with this length, this line at an angle as the hypotenuse, with the x-axis as one of the sides, and with a vertical line as the opposite. Right, so in this case 360 minus 330 is 30 degrees. Again, I'm using this special angle as an example. Now suppose that the hypotenuse is 2, then we have this opposite side 1 and the adjacent √3. Right, the adjacent is along the positive x direction, so it's just a positive number. The 1, the opposite, is pointing in to the negative y direction, so it's really a -1. Alright, so we have the sines. Then we can now find the sines and cosines. The angle is 330. So sine 330 degrees is the opposite over hypotenuse. -1 over 2. Minus half. Cosine. Cosine 330 degrees. Adjacent √3 over 2. Positive √3, so a positive number. Finally, tangent 330 degrees. Opposite -1 over √3. A negative number. So this is how we would get the answers and the sines for angles in all 4 quadrants of the graph, or of the xy plane, as we call it. Now sometimes you might be given a number, say you might be given the sine or cosine of 30 degrees, and then you'll be asked to find the sine of 330 degrees. Now in that case, you will need to work out the sines, whether sine of 330 degrees is a plus or a minus. Now there is a way to help you to remember that. Of course, you can simply sketch out the triangle and work out the sines using the formula, which is the way that I prefer to do it. But some people prefer to memorize it directly. So if you prefer that, so that's the 1, 2, 3, 4 quadrants. Right. Now we have sine, cosine and tangent, three trigonometric ratios to think about. Now the way to remember is to say that in the first quadrant, all are positive. Alright, this means that all sine, cosine and tangent are positive if the angle is in the first quadrant. Now if the angle is in the second quadrant, meaning if we have something with an angle between 90 and 180 degrees, then only the sine is positive. If we have an angle that is in the third quadrant, only the tangent is positive. And if you have an angle that is in the fourth quadrant, then the cosine only is positive. You can remember this by remembering the first letter there and think of it as ASTC. ASTC.